Hello. Good evening all. Audio, video clear. Yes, so welcome all of you. Hello. I'm good, Omkar. Hope all of you are good. Good evening, all of you, Kavita, Subhashini, Vaneshri, and all of you. Okay, so welcome all. Yeah, today was a very hectic day, and all of you, as I told from the beginning, please encourage the educator. Please don't discourage the educator who are taking class. Educator will be doing a lot of things in the day, and after a lot of things or after a hectic day, he will be coming to take class in the evening for all of you. So at that time, discouraging words, try not to do it. That is a gentle request to all of you. So because to be frank, it was a very hectic day, and I was in hospital actually today morning. After that, encouraging words will be very welcome. So all of you, be encouraging to your educators. That will be good for educators to continue, or that will be encouraging for educators to continue. Okay, so let us start. Welcome all of you. Anagrams and number rearrangement, that is the question we are discussing. That is a topic we are discussing today. Okay, so let us start. Yesterday we discussed, or last class we discussed about fundamental principle of counting. So fundamental principle of counting, multiplication rule and addition rule we have discussed. We are continuing that today also. I mean the logic behind fundamental principle of counting, that is needed for today's class also. Anagrams and number related problems, that is what is needed. Fundamental principle of counting, multiplication rule especially. So I hope all of you are clear about fundamental principle of counting. If there is any doubt, check out the previous lecture, those of you haven't attended last class. Okay, so let us start. Fundamental principle of counting, multiplication rule is one thing. If one thing can be done in m ways, and another thing in n ways, both the thing together can be done in m into n ways. That is what we have discussed last class. This idea is very important in today's class. Let's see a question and understand today's concept clearly. Then we will go to CSIR-NET or other exam questions also. First, let us get clarity of the concept with these questions. Make a try, all of you. Very good. Some of you already got the answer. Okay, so here let us understand how fundamental principle of counting is useful here. First of all, anagram means word rearrangements. Here there are 4 letters A, B, C, D. With that, how many words can be formed? That is the meaning of different ways the letters can be rearranged. Now, rearrangement only possible. You cannot repeat the letter multiple times. A, B, C, D are 4 letters. So only 4 letter words can be formed. That is the idea in these kinds of questions. So 4 positions are there, right? Just like yesterday we discussed in the last questions. Here there are 4 positions to be filled. The first position can be filled in how many ways? First position can be filled with A letter, B letter, C letter or D letter. Any one letter can be used now. Compare this question with yesterday's question. We discussed a question of 2023 NET exam now. level, palindrome. Here there is no palindrome, it is easier than that. But the idea of solving the question is the same itself. Here there are 4 ways to fill the first position. Now whichever letter you fixed here, if you are fixing A here, you cannot fix A here also, because A is only once. But you can fix B, C, D. But if you are fixing B here, you can fix only A, C, D. If you are fixing C, you can fix only the remaining 3 letters. If you are fixing D, you can fix only the remaining 3 letters. That means here if there are 4 possibilities, here there are only 3 possibilities. And here there will be only 2 possibility, and here there will be only 1 possibility. So now using fundamental principle of counting, 4 into 3 into 2 into 1 will be the total number of ways. Because just like yesterday we discussed, here 4 things, here 3 things, here 2 things, here 1 thing. So how many ways mapping can be done? This is 1, this is next, this is next, this is next. Then with the second one you can do the next one. Again, we discussed this idea in detail in the fundamental principle of counting lecture. So 4 into 3 into 2 into 1, that is written mathematically as 4 factorial. 4 into 3 into 2 into 1 is called 4 factorial in maths. Some of you are not of the math background, that is why I am just telling that. Most of you know factorial, I guess. In case not, just understand n factorial means n into n minus 1 into up to 1. You have to multiply till you reach 1. So 4 factor means 4 into 3 into up to reaching 1, you have to continue that. That means in general you can say if it is n letter word, if all letters are different, n factorial rearrangements are possible. All of you understood this concept clearly? Now let us see one more example of this so that the concept is very clear. Try this. Many of you got it right already. Very good, very good. So how many different ways can the letters A, B, C, D, E can be rearranged? So first position can be filled with A or B or C or D or E. 5 ways to fill that. A or B or C or D or E. And second position can be filled with 4 ways only, because the letter that you already fixed cannot be used here. Now third position can be filled only in 3 ways, because the letters used here and here cannot be used anymore. Here only 2 ways, here only 1 way. So total number of ways will be 5 into 4 into 3 into 2 into 1. Or we can say 5 different letters, so 5 factorial is the answer. 5 into 4 into 3 into 2 into 1 is 120. All of you understood? Now let us twist more this question, and this is how questions are repeatedly asked in NET exam, GATE exam, UPSC exams, UGC NET exam, etc. This model question. Anagram, this model question. All of you make a try. Okay, some of you got the answer. Listen very carefully, I will explain this. In how many ways can the letters A, B, C, D, E Previous question also A, B, C, D, E was there. Be arranged such that B and D are always together. B and D are always together. Always together means there is no letter in between B and D. That means we can consider B and D as a single letter. BD as a single letter. BD as a single letter. Shoaib, in the book this is there in the probability and arrangement chapter. Probability and arrangement chapter in our book. That is the chapter where this topic is mentioned. So BD is a single letter. Remaining letters are A, C and E. A, C and E. So BD, A, C, E. That means one letter, second letter, third letter, fourth letter. So 4 letters are there total. So 4 letters are there total. 4 letters can be rearranged in how many ways? 4 factorial ways. Now that is already clear. 4 factorial is 24, but that is not the correct answer because BD can be together in one more way. DB is also another possibility. Are you agreeing? B after that D, D after that B, that are 2 different possibilities. That means this also have 4 factorial 24 arrangement. Now fundamental principle of counting addition rule says this thing, that thing, this or that can be done in m plus n ways. M ways, n ways. So this or that can be done in m plus n ways. M plus n ways means 24 ways for this to happen, 24 ways to this to happen. So 24 plus 24, 48 ways for this or that to happen. So total 48. Or in other words, multiplication rule also can be used. Internally, another way to look at it is internally BD and DB are the rearrangements possible, or there are 2 factorial rearrangements possible internally. BD, there is a letter group. That letter group can be rearranged in 2 factorial ways. Now externally BD as a letter, ACE as 3 more letters, that is 4 letters can be rearranged in 4 factorial ways. So internal arrangement into external arrangement, that is how this question can be abstracted and done more mathematically faster. So 2 factorial into 4 factorial, that is 2 into 24, that is 48. All of you clear? This to understand the concept I told you, then we can generalize it like this: internal arrangement into external arrangement. All of you clear? Then what about this question? This is the next type that can be asked. Make a try, all of you. Some of you already got an answer, very good. Okay, so here the complement idea can be used. The last to last question we discussed, ABCD can be rearranged in 120 ways, 5 factorial ways. The last question we discussed, ABCD can be arranged such that B and D can be together in 48 ways. So B and D not together means from the total arrangements, if you subtract BD together arrangement, B and D together arrangement, you will get the answer. Na? Total arrangement is 5 factorial, we already discussed, 120 it is. BD together arrangement we discussed in the last question, 2 factorial into 4 factorial, internal arrangement into external arrangement, that is 48. If you subtract this, you will get the remaining. Na? If the letters are not together, if the letters are together or not together, these are the only 2 things possible. Na? So if the letters are together, then they are not together. If they are not together, they are not together. So that means here it is 120 minus 48, 72 is what we need. So option B, 72. All of you got this clearly? Please respond. So this you can try as homework. A, B, C, D, E, F, 6 letter and A and C together, and option B will be the correct answer. A and C never together. Then can you do another question? Let us understand this concept more clearly with this question. Make a try. Rhea, probability also will be covered. As I told, many things are coming in between. Due to some medical emergency also I was busy some days. That is why I am telling it is very important that you people also motivate the educators to take sessions. So be positive. That is one advice I want to give you all. Be positive to everyone. So D option, I think now it is okay. It is not visible. I will just adjust the slide then. Probability will be covered after this permutation topic, permutation combination topic. As I told, last class, today's class, next class, next to next class. Two more classes will be permutation combination. After that it will be probability topic itself. So try this. Okay, many of you got it. Very good. So instead of ABCD, it is YEARS now. It is YEARS. So same way you can do. YEARS is 5-letter word. 5-letter word can be rearranged in 5 factorial ways now. 5 factorial, that is 120 ways. So option D is the correct answer. Super easy, right? Now if the question is asking vowels can be together, that is another way the same question can be asked. Vowels can be together. Make a try, all of you. So due to lack of time, I will start explaining. The vowels are A, E, I, O, U in English. So here the vowels that is available is E and A. So they should be together. That means they should be considered as a single letter. EA as a single letter. EA a single letter and YRS as 3 other letters. So total 4 letters can be rearranged in 4 factorial ways. They should come together. But EA can be internally rearranged in 2 factorial ways. So 2 factorial into 4 factorial. 2 into 24, 48 is the answer. Same logic itself. Now you know how to do vowels not coming together also. 120 minus 48, 72 itself. Option A will be the answer for this question. Super easy. Now let us see a CSIR-NET problem to understand this concept or see how questions were asked in CSIR-NET from this area. All of you make a try. In GATE exam also this was asked, the same type question. Okay, some of you got option B, some of you got option C. So this is the next important thing you should understand in anagram problem. In all the previous question we discussed, the letters were not repeating, but here letters are repeating. For example, C and C is occurring, two times C is occurring now. If all letters were different, I agree that total number of rearrangements will be 6 factorial. 6 letters, 6 factorial. 6 factorial, when you do it, you will get 720. That means you are saying that 720 words can be formed from chance itself by rearranging them. By rearranging chance, 720 words are possible. But many of them are duplicate words. For example, if I am rearranging, like if I am taking the C and keeping it here and this C to here, will that change the word? No, the word will be still chance. But if the word was change instead of chance, when you put this G here and C here, that is a new word. G-H-A-N-C-E, that is a new word. Are you all understanding? That means in the 720 arrangements, all these duplicated words are there. Which duplications? By rearranging C, you are getting duplications now. Not only this word, I mean not only C-H-A-N-C-E. If this C is placed here and this C is placed here, you will get H-A-C-N-E-C. Yeah, I think that this is how the rearrangement is done. Now this C if you place here and this C is if you place here, are you getting a new word? No, it is the same word itself. So to delete the duplication, you have to divide by how many letter, the letter that is occurring R number of times, that R factorial you have to divide by. That means chance 6 letter word. 6 letter can be rearranged in 6 factorial ways, but to delete the duplications you have to divide by 2 factorial, because 2 letters C is occurring 2 times. So 2 factorial you have to divide by, that is 720 by 2, 360 it is. All of you understood this, why you are dividing by 2? If you are not understanding, I will take another simple example to explain this. E by E, how many ways E by E can be rearranged? Let us list it out. Yeah, we know it is 3 factorial if all the 3 were different, but 3 factorial by 2 factorial you should do, that is what I am telling. 6 by 2, that is 3. Why it is 3? Let us understand it by listing them, because listing this many arrangements is not a big task. E by E, fixing E here, you can rearrange EEY also, EEY also. Fixing Y here, YEE is possible. Now fixing Y, if you rearrange this E and D, you will get YEE. Now fixing the last E here, EYE is another word, EEY is another word. But here, these 6 words, many are duplicates. Now. These 2 are identical, these 2 are identical, these 2 are identical. That means half are duplicates. So you are dividing by 2 to delete the duplicates. All of you are understanding this? Why we are dividing by 2 factorial or 2? So 3 words only are there in EYE. Similarly here, chance, it will be 6 factorial by 2 factorial. All of you understood? This was a previous CSIR-NET problem. More explanation is given here. If there is any more doubt, please ask. All clear, all of you? Now I will show you variations of this question. Instead of CHANCE, if it was CHANCC, CHANCC, CHANCC is a 6 letter word itself, but C is occurring 3 times. C is occurring 3 times means that C's can be rearranged in 3 factorial ways. So you have to divide by 3 factorial. Because these all words are same. As an example I am telling. C, C, C. If you rearrange C1, C2, C3, you are not getting different words. Kaushiki, I will come to that question also. That type of question also. All of you understood this? Dividing by 3 factorial idea. So it will be 6 factorial by 3 factorial. 6 factorial 720, 3 factorial 6. 720 by 6 will be the answer. Now if the word was CHANCN, CHANCN, listen very carefully. N is occurring twice, C is occurring twice. Then you have to divide by 2 factorial and another 2 factorial. 6 letters, 6 factorial ways. Divide by 2 factorial and another 2 factorial. Don't divide by 4 factorial, that is wrong. 6 factorial divided by 2 factorial into 2 factorial. All of you understood? That is 720 divided by 2 into 2. That is 360 by 2, 180. All of you understood this? These are the variations that are possible. These are the variations that are possible. Then try this. I think Kaushiki, this was the type you were asking. Try this question. December 2012 net exam problem this was. These are called anagram problem. Word rearrangement is the idea here. Okay, due to lack of time, I will start explaining. UGC CSIR have 7 letters or 7 factorial arrangements if all were different. But we need U and I not coming together. So U and I coming together, you find it. UI together. That arrangement, if you subtract from total arrangement, you will get the required answer. Total arrangement is 7 letters or 7 factorial divided by 2 factorial. Why dividing by 2 factorial? Because C is occurring twice. C is occurring twice. C is occurring twice, so you are dividing by 2 factorial. Now, 7 factorial by 2 factorial, if you calculate it, you will get 2520. 2520. So that 2520 will be the total arrangement. From the 2520, you have to subtract what? Just a minute. 2520, you subtract UI together combination. UI together combination means U and I as a single letter, UI as a single letter, and other words GCCSR as different letters. 1 letter, 2 letter, 3 letter, 4 letter, 5 letter, 6 letter. So 6 factorial ways. 6 factorial ways. But there, listen very carefully. CC is repetition, so you have to divide by 2 factorial again. Now UI can be rearranged in IU also, so you multiply by 2 factorial. So this you need to subtract from this. 2 factorial cancels, so that is 720. So 2520 minus 720, 1800. Option D is the correct answer. How many of you understood this? Please respond. Here repetition of letter idea is also there, and letters not coming together idea, both are there. Both we discuss separately. Here it is coming together. That's the only difference. Here the division of 2 factorial because the letter C is occurring twice. Here the multiplication of 2 factorial because UI can be rearranged in 2 factorial ways. All clear? So this is how to do anagram problems. Anagram problems can be done like this. So now the same idea can be used for numbers problem also. Very fast I will discuss that in next 5 minutes very fast. So yeah, one thing actually we are in the beginning itself we told half an hour sessions, and every day we have taken half an hour. Some people are saying it is 20-minute session. Please check out all the previous videos. Every session is minimum 30 minutes. I think only one day it was 29 minutes some 10 seconds. No day lecture was 20 minutes. So I don't know why some people are finding finding mistake in everything. So check the previous videos, those of you have further doubts. Okay, so as I told, we have started the series as 30 minutes series, where 30 minutes you learn maximum content in 30 minutes. So that will be continued, and that is how this course will go. Okay, so this idea of anagrams can be extended to numbers also. How you can extend this idea to numbers also? Let's see. For example, 1, 2, 3, 4, 5. Or first let us see a question which is very relatable to the previous question. So okay, this question due to lack of time I will start explaining. You people can try also. So how many 5-digit numbers can be formed with the digits 1, 2, 3, 4, 5 without repetition allowed? That means the letter number that is used should not be repeated. Just like anagram problem, the letter that is used is not repeated. Here the number that is used is not repeated. So how many ways can be possible? 5-digit numbers. 5-digit numbers means leftmost position can be filled in 5 ways. 1 or 2 or 3 or 4 or 5. 5 ways. The number used here cannot be used here. So 4 ways only here. The letter numbers used here and here cannot be used here. So 3 ways only here. 2 ways only here. 1 way only here. So total number of ways will be 5 into 4 into 3 into 2 into 1. 5 factorial ways. Same idea as anagrams. All of you understood this? Thank you so much Anshika, Shama, Mampi. So 5 factorial. But this question can be asked this way also. With the repetition allowed. What about repetition allowed case? Repetition allowed means the number used can be used again also. In that case what will happen? You can use 1 or 2 or 3 or 4 or 5 here. Here also 1 or 2 or 3 or 4 or 5 here. The number already fixed may be repeated also. That is why here also same, here also same, here also same. So that is 5 into 5 into 5 into 5 into 5. Fundamental principle of counting, multiplication rule. That will be 5 raised to 5. Or in general you can say n raised to n. If n positions are there, n numbers are to be filled with the repetition allowed. With the repetition allowed means the number used can be repeated again also. That is n raised to n or 5 raised to 5 in this case. If it has 10 letter number, 10 digit number and 1, 2, 3, 4 up to 9 and 0 also, yeah, then there is a problem. Leftmost position cannot be 0. That is another thing that we will discuss on another class if time allows. Now, instead of 5 digit, what about 3 digit or 2 digit or 4 digit? What will happen then? For example, this question. There again fundamental principle of counting only needed. How many 3 digit numbers can be formed with the digits 1, 2, 3, 4, 5 with repetition allowed? 3 digit numbers. 3 digit number means 3 positions only. With repetition allowed means 5 numbers, 5 numbers, 5 numbers. So 5 into 5 into 5. 125. 5 cube. If repetition is not allowed, what will happen? Without repetition of digits, 3 position, 5 numbers possible here. The number used here cannot be used here, so 4 ways only. The numbers used here and here cannot be used here, so 3 ways only. So 5 into 4 into 3 it will be. 5 into 4 into 3. All of you understood this? 5 into 4 into 3, that is 20 into 3, 60 it will be. First option 60. So these are some of the variations. So 60 will be the correct answer here. Anshika, we are working on it. Actually, we are finding some difficulty in preparing that material in the proper format. We are working on it. Soon we will update. That is what I can say. As I told, many things come in between, or many things came in between. That is the thing. Okay. Anyway, all of you understood how 60 is the answer? So this question again, other variations of this is, for example, how many 3-digit odd numbers can be formed with the digits 1, 2, 3, 4, 5 with the repetition allowed and without repetition allowed. Let us discuss without repetition first. Odd number means the last digit should be 1 or 3 or 5 or 7 or 9. But here only 1, 3, 5 are the possible odd numbers. So unit place only we need to fill. Unit place should be either 1 or 3 or 5. So 3 possibility only. 3 possibility only. But tens place can be 1 or 2 or 3 or 4 or 5. Odd number, unit digit should be odd number. Remaining digits can be anything. But here 1, 2, 3, 4, 5 only. But the digit already used here cannot be used here because it is without repetition case. So total 5 digits, 4 digit only remaining. Now the digits used here 2 digits already used here. That means here only 3 digits remaining. Possibilities 3 possibility only remaining. So 3 into 4 into 3 will be the answer. 3 into 4 into 3, that is 36. Here the constraint was on the unit digit. That is why we are starting from the unit digit. Constraint was from the unit digit. That is why we started on the unit digit. Noodle, what is the doubt on the previous question? Previous question, it was 3 digits, 3 digit number. So only 3 positions to be filled. Units, tens and hundreds. If you start from left or right, no, both are okay. If you start from left, 1 or 2 or 3 or 4 or 5, so 5 possibility. Here the number used here cannot be used here, so 4 possibility only. Number used here and here cannot be used here, so 3 possibility only. So 5 into 4 into 3, total 60 possibility. So this is how number related problem. Again, the theory is same as anagram. Now I will show you a little more trickier number related problem, and by that we will conclude today's class. The latest NET exam problem, June 2023 NET exam problem. All of you try this. Okay, due to lack of time, I will start explaining the possible number of integers between 1000 and 10,000 containing 2 2's, 1 0 and 1 3. For example, 2 0 2 3 is an example. 2 2's are here, 1 3 is here, 1 0 is here. That means here constraints are more. You should understand constraints are more. There you should be very careful. 2 2's are there, so 2 and 2 available. That means 2 repetition is allowed only. Total 2 times it can occur, but 0 cannot be repeated, 3 cannot be repeated. That is the meaning. And the number should be between 1000 to 10,000. That means it cannot start with 0. Na? That is another constraint. I mean leftmost digit cannot be 0. All of you understood why leftmost digit cannot be 0? For example, if I write a number 0, 2, 2, 3, all other conditions are satisfied except between 1000 to 10,000 condition, because this is not a number between 1000 to 10,000. For the number to be between 1000 to 10,000, it should be a 4-digit number. 4-digit number. 4-digit number means leftmost number cannot be 0. Then it will be 3-digit only. Na? That is why this is a position where we have a constraint. So start from the constraint. That is the idea I told you. So here 0 cannot be fixed, but 2 or 3 can be fixed. Na? 2 or 3 can be fixed. All of you understood 2 or 3 can be fixed? Yeah, this 2 or this 2, that is not different 2's. That is the same 2 itself. So 2 possibility only. 2 or 3 are the 2 possibilities for the leftmost position. That means you used either a 2 or a 3. All of you clear? Either a 2 or a 3. That means for this position, either that 2 used is not available or 3 used is not available. That means among 2 and 3, one number is remaining and another 2 is there actually. If you are using 3, yeah, here you should be a little careful. This is a little tricky one. So here, if you fix, for example, I'll do one thing for making it easy. Let us take 2 cases. If the first position was 2, starting with 2, what all possibility? Why we are writing this? Because there are 2 branches actually here possible. The leftmost position being 2, leftmost position being 3. Why we need to take it separately? Because if this is 2, one more 2 is available. But if this is 3, 2 2's are available. But at a position only 1 2 can be used. So that is why if you are fixing 2 here, one more 2 is available, one more 3 is available, one more 0 is available. All these are okay for this position. That means 3 ways to fill this. But the number already used here cannot be used here. So 2 ways only here. And number already used here and here cannot be used here. So 1 way only. Again, don't get confused with the number 2 and the possibility, 2 possibilities. So starting with 2, there are 3 into 2 into 1 ways. That is 6 numbers possible. 6 numbers possible. Now starting with 3. Once you are fixing 3, 3 is not available anymore. 2 more 2's are available, 1 0 is available. 2 more 2's means only 1 2 can be used at a time. That means here either 2 or 0, 2 possibility only remaining. Either 2 or 0, 2 possibility only remaining. Two possibility only remaining. If you are fixing 2, if you are fixing 2, one more 2 is remaining. That means 2 possibility here also. Yeah, there actually you can start with 32. Here one more thing. You start with 32. 3 here and 2 here. That is another branch possible. In that branch, what all are possible? Here either you can fix another 2 or 0. So 2 ways. Here only one way. Remaining number is the only one way. That means 2 ways into 1 way. Total 2 ways. This I know that this is a little confusing. To avoid confusing, I will just list out the numbers also so that it is more clear. But let us first finish this. So 3 2 starting, now 3 0 starting. If it is 3 0 starting, 3 0 starting means here it can be either 2 or 2. That means one way only. And here the remaining 2 should be used. That means only one way. So total 6 plus 2 plus 1, 9 ways are there. Again, this is little confusing. That is why I will show you what are the 6 ways. Once you fix a 2 here, 3 into 2 into 1, 6 ways are there, because you can fix a 2 here, 0 here, 3 here, 2 0 3 is one possibility, 2 2 3 0 is another possibility. Now fixing 3 here, 2 3 0 2 is a 2 3 2 2 is a possibility. Now fixing 0 here, 2 0 3 2 is a possibility, and 2 0 2 3 is a possibility. 2 0 2 3 is also a possibility. So, and which one I have missed? 2 0 possibility. Sorry, this is 2 0 2 0, 2 3 2 0 and 2 3 0 2. There are 2 possibilities. These are the 6 possibilities I mentioned with 2 in the beginning. 6 possibility. Now with 3 in the beginning, there are 3 possibilities. What are they? 3 2 2 0, 3 2 0 2. 3 2 2 0, 3 2 0 2. Now with 3 0 in the beginning, 3 0 2 2. These are the 3 possibility with 3 in the beginning. 2 in the beginning, there are 3 possibility, 6 possibility. 3 in the beginning, 3 possibility. So 6 plus 3, 9 possibility. I know this was little trickier. This was the toughest question asked from this area in CSIR. This was not very tough, but compared to previous question, this was little tougher. Hope all of you are clear. Is it clear? All of you, please respond. Thank you so much, Manya. Yeah, I remember. Most of the students I remember. I remember in the class students were mentioning it should be Manya or Manya. I remember that instant. Hope it is the same Manya itself. Students told me that the pronunciation should be Manya, not Manya. Okay, so anyway, all of you understood this. 2302 is already written, Sergeant. 2302 is already written here. Here, the fourth one. Okay, so all of you clear? Yeah. This was a little tougher one. The remaining questions all, I hope it is clear. So this is anagram idea and number rearrangement idea. Once again I am telling, this is just fundamental principle of counting, multiplication rule and addition rule. Factor में 3 कैसे आया? First case or second case, Mampi? You are saying about second case or first case? Yes, Shruti, most days classes happens. Some day due to schedule issue or due to health issues, I don't take. Some days again timing constraint is the main thing. So happy to hear, Manya. So happy to hear. Thank you for the good words. So as I told, encouraging words from students is the best gift any teacher can get, because that will motivate teachers a lot. Okay, any other doubts on this in general? I have explained many lectures on this permutation combination or arrangements. The topic name will be different, but all these are actually same chapter itself. Arrangements, anagrams, number rearrangements, permutation, combination, fundamental principle of accounting, all these are related topics. So my lectures on any of these topics are there, you can check out that. So 3 left ke baad, let me check. Good to hear, Shruti. Yeah, I remember the name Shruti. So good to know that many of you have attended my classes in other platforms also. Yeah, just let me know who all have attended my classes in other platforms also. Like to hear from all of you, because when I resigned from the other platform, I was not sure whether the students are also with me, but many people actually texted after that also. That actually motivated me to come up with the series actually. So okay, I think today we can conclude here. Remaining doubts or remaining questions I will answer tomorrow. Okay, Omkar, yeah, I remember your name particularly. You were one of the students who were answering the questions super fast. I remember you. So good to see all of you here in this platform. Yes, Rajkumar, I remember you also. Okay, Mumpy also, Anam also, many of you were there attending my classes. So good to hear. Yeah, as I always told before also, in that platform also, that platform was actually very good for students, whatever was the policies, but for students it was good only. And I was also grateful that I was able to reach to more and more students through that platform. That way it was, I will be always grateful to that platform in that regard, that we could reach to more and more people. That is a very encouraging thing for any educator, seeing more crowd and addressing more crowd in a single class. Okay, Batula also, Kaushiki also, many of you have attended my previous classes in those platforms also. Good to hear. Welcome, Madhunala. Okay, so let us conclude here. Thank you all of you. Do let me know what you felt about this session. Again, the things that is missing or things that is needed extra, check out my other videos in this channel. For GATE exam also I have taken a chapter, permutation combination. In the GATE playlist it is visible. There I have explained similar questions of this type which came in GATE exam. So through that you will get practice. Even if you are not preparing for GATE also, those questions will be useful for your CSIR preparation also and other exam preparation also. So GATE 2024 General Aptitude course I have taken permutation combination chapter. So that's it. Thank you all of you. Take care all of you. Have a good night. See you all on the next class. Bye bye.